Good morning, everyone. We're back once again with another amazing science tutorial video, and I'm excited today because I got some feedback from my students. And so shout out to Katoria Parker and Mackenzie Thorpe because they said, Coach Spivey, we need you to go over Monohybrid Cross and make a video on that. We want you to go more into detail so we can understand it. So for the two of y'all, I got you. And for everyone else that need a video on Monohybrid Cross, I got you. We're going to go into detail today. So let's go ahead and begin. So the first thing we're going to look at is Punnett squares. So Punnett square is a method invented by English geneticist Reginald Punnett in the early 20th century. And it's one of the easiest ways to calculate the mathematical probability of inheriting a specific trait. It shows the potential genotypes, which are those letters, and phenotypes, which is the physical makeup of offspring based on the genotypes of their parents. So if you look, one thing that a lot of people don't pay attention to is this is the process of meiosis occurring. So you're looking at, here are the father's genes, here are the mother's genes, and remember when a sperm fertilizes the egg, we have fertilization. So these are all the different possibility of offsprings or kids that your parents can have. So let's take a look at it. A monohybrid cross is based off the first law of genetics, which is the law of segregation. So the law of segregation says if this is your dad, and I put a D for dad, he can give you one of two alleles. And these alleles are separate. They don't come together. And then say if this is your mom, I put an M for mom. Same thing for mom. She can give you one or two of these alleles. She can give you either a big B or a little b in this example. So we notice, we look over here, I'll make it even simpler for you. Here's dad right here. And then here's mom. Here are the possibilities. So we have our big B, that's going to give us a purple flower. Big B, little b, that gives us a purple flower because remember, the big B is dominant over that little b. That's why it's going to be heterozygous. And then we look right here, we have a big B, little b. Here's another heterozygous dominant, another purple flower. But then if we look right here, we have little b, little b. So this is homozygous recessive. That's why you see that white flower there. So now, how to set up a Punnett square. So we're going to cross two things. We're going to look at homozygous tall, which is right here, big T, big T. So let's put that across the top. And we're going to cross it with homozygous short. Homozygous short is going to be little t, little t. Notice that tall is going to be the dominant trait. So that's why you have a big T or a capital T. Short is going to be the recessive trait. So let's go ahead and cross these two. We have big T, little t, big T, little t, big T, little t, and then we have big T, little t. If you notice, all four of these are the same. So when we look at our genotypic ratio or our letter combinations, we're looking at it's 4-to-4 because all four of them are heterozygous dominant, 100%. And remember, heterozygous just means there's going to be two different ones. So I'm going to have a big T and a little t, or a big letter and a little letter. So let's look at our phenotypic ratio. So that's the physical trait that's going to show. Notice that all four of them are going to be tall. Why are they going to be tall? Because remember, your dominant trait is going to mask or hide that recessive trait. Now, you're going to do your own practice problem. Now, you're going to be looking at heterozygous tall. Remember, take this and we're going to put this across the top. Heterozygous tall. And then you're going to be looking at another heterozygous tall. So I'm going to take this and put this across the sides. Ladies and gentlemen, you have 1 minute to set up and solve the problem, and I'll start it beginning now. So now, ladies and gentlemen, let's check out how you did on this first practice problem. So we have a heterozygous tall crossed with another heterozygous tall. So now when we cross it, for this first one, we have homozygous dominant right here. We cross this next one, we have heterozygous dominant. We cross this next one, we have heterozygous dominant, and then this last one we have homozygous recessive. So now let's look at our genotypic ratio. We have one homozygous tall, so there's that one right there, and then we have two heterozygous tall. So here's two heterozygous tall right here, and then we have one homozygous short. So our genotypic ratio is 1-to-1. I even break it down for you up here. Now let's look at our phenotypic ratio. So phenotypic ratio, how many of them are going to be tall? If you look, 3 of them are going to be tall. How can we tell? Because there are at least 3 of them that have a big T. And remember that big T is dominant over that short T. So 3 of them are going to be tall and 1 is going to be short. So the ratio is 3 to 1. Now, ladies and gentlemen, you have 1 minute to set up and solve the problem. You got 1 minute beginning now. So now let's check and see how you did on this practice problem, this second practice problem. So we have a heterozygous purple across the top, crossed with a homozygous white going across the sides. So now let's go ahead and cross them. So I have a big P, little p, so we have heterozygous dominant right here. Cross these two, we have a homozygous recessive. Cross these two, we have a heterozygous dominant right here. And then cross these last two, and we have homozygous recessive. So now let's look at our genotypic ratio. If you notice that we have 2 that are heterozygous dominant. So there's 2, and then we have 2 that are homozygous recessive. So here's another 2. So we have 2 to 2. I'll break it down even further for you up here. So heterozygous dominant, we have 2, which is going to be big P, little p. Homozygous recessive is going to be 2, which is going to be little p, little p. Now let's look at our phenotypic ratio. It's going to be 2 to 2. So 2 are going to be purple and 2 are going to be white. I know you did wonderful on that. Let's move on to the next problem. Now let's take a look at our next problem. Now this next problem is a word problem, and people tend to struggle so much with word problems because it's hard for them to identify what they need in order to solve the problem. So on this first problem, I'm going to go ahead and go through with you on what you need in order to set up and solve the problem. So let's get started. It says a dog is heterozygous for curly hair. That's important information, so we're going to underline that. And is mated with a dog homozygous for straight hair. That's more important information, so we're going to underline that as well. Straight hair is recessive. What are the different types of hair that the puppies could have? So now, as a rule of thumb for me, what I do is I always circle the first letter of the dominant trait. How do I know? So we're looking at curly hair and straight hair. How do I know curly hair is dominant? Well, it says right here that straight hair is recessive. So I'm going to circle that first letter, and that's the letter that I'm going to use for this problem. Now, if you know what you're doing, then you can use any letter that you want to. But if you don't know what you're doing, then you need to walk with me. I need to hold your hand through this process. So follow along with me. So if it's a dog that's heterozygous for curly hair, we're going to have a big C and a small c. If they're homozygous for straight hair, remember straight hair is recessive, so we're going to have 2 small c's going along the sides. And then we're going to do our usual cross. So I'm going to cross my genotypes, big C, then little c, little c. Now we're going to go ahead and look at our genotypic ratio. Our genotypic ratio, I have 2 heterozygous dominant, so that's going to be 2 right there. And then I have 2 homozygous recessive, so 2 to 2. I'll even put it up here for you. So heterodom is 2, and then homo recessive is 2. And to help people out, I even put those letters above it. So let's put a big C, little c right there so people know where we came from with that. Then our phenotypic ratio, notice heterozygous dominant, so that means 2 of them are going to have curly hair. 2 are going to have curly hair, and then 2 are going to have straight hair. So it's going to be 2 to 2. So curly equals 2, and then straight, and I'll abbreviate that, equals 2. So curly hair, how many are going to have curly hair? That's going to be 2, or 50% of them. How many of them are going to have straight hair? That's going to be another 2, or 50% of them. Now, you have 2 minutes to set up and solve the next problem. So even before we do our 2 minutes, for the people that need more help with this, I'm going to go ahead and start underlining the stuff that you need. You need homozygous for white fur. You need homozygous for gray fur. It says white is recessive. So that means gray fur is going to be that dominant trait. So we're going to be using the G for this one. So homozygous for gray fur, I'm going to go ahead and help you even more. We have big G, and then homozygous for white fur. That means we're going to have 2 little g's over here. So now we've just underlined the important parts. We've just set it up. You have 1 minute now to go ahead and solve the following problem. And I give you that 1 minute beginning now. Ladies and gentlemen, let's see how you did on this problem. So we cross homozygous dominant with homozygous recessive and we're looking at the fur, the color of the fur. So now we have, when we cross, all 4 of these are going to be heterozygous dominant. So let's look at that genotypic ratio. It's going to be 4 out of 4. All 4 of them are going to be heterozygous dominant right here. And I even break it down up above. And then if you notice a phenotypic ratio, all 4 of them are going to have gray fur. 0 of them are going to have white fur. And then you look right here. Well, this is pretty simple. Gray is going to be all 4 or 100%. White is going to be 0, which is 0%. So now you have 2 minutes to set up and solve the following problem. Remember, go ahead and underline the important stuff that you need. I give you those 2 minutes beginning now. Now let's see how you did. So you should have underlined heterozygous for gold flowers, homozygous for yellow flowers, and then yellow is recessive. Since yellow is recessive, that means that gold trait is going to be dominant. So I circled that G. So I have a heterozygous for gold flowers, a capital G, lowercase g, and then homozygous for yellow flowers. I have 2 lowercase g's going across the side. And we're going to go ahead and cross those. So if you notice, I cross these. I have heterozygous dominant, homozygous recessive, heterozygous dominant, and then another homozygous recessive. So our genotypic ratio is going to be 2 to 2. 2 of them are heterozygous dominant, and then 2 of them are homozygous recessive. Then if we look at our phenotypic ratio, 2 are going to be gold and 2 are going to be yellow. So then gold right here is going to be 2, yellow is going to be 2. Let's take a look at this next problem. It says a person with a heterozygous genotype for freckles has a child with a person with a heterozygous genotype for freckles. What could the genotype and phenotype be for the child? Set up a Punnett square and show the genotypes, phenotypes, and ratios. So now let's go ahead and look at heterozygous genotype for freckles. So we're going to circle the F because that's what we're looking at. So heterozygous, that means we're going to have a big F and a little f. And then heterozygous genotype for freckles, we're also going to have another big F and a little f. So let's go ahead and cross these. I have homozygous dominant here, heterozygous dominant here, heterozygous dominant here, and then we have homozygous recessive. Our genotypes are going to be the different types of letter combinations. So we have one homozygous dominant, we have heterozygous dominant, and then we have homozygous recessive. So our genotypic ratio is we have 1 homozygous dominant, we have 2 heterozygous dominant here, and then we have 1 homozygous recessive. So our genotypic ratio is going to be 1 to 1. Our phenotypes, we're going to have phenotypes, you're going to have with freckles. Now I'm going to put with freck. And then I'm going to put no freck. Our phenotypic ratio, 3 are going to have freckles because we have that dominant trait showing. So 3, and then we have 1 no freckles. So it's going to be 3 to 1. So ladies and gentlemen, you have 2 minutes to set up and solve the following problem, and I'll start those 2 minutes beginning now. Let's take a look and see how you did. So you should have underlined homozygous dominant genotype for earlobes, homozygous recessive genotype for earlobes. So if you look at our genotypes, we only have 1 possible genotypes because all 4 of these are the same. So that's heterozygous dominant right here. Our genotypic ratio is going to be 4 to 4. And then if we look at our phenotypes, all 4 of them are going to have earlobes. And then our phenotypic ratio is 4 to 4. Ladies and gentlemen, you have 2 minutes to set up and solve the following problem, and I'll start those 2 minutes beginning now. Now let's take a look and see how you did. On this problem, you should have underlined homozygous recessive genotype for short eyelashes and heterozygous genotype for long eyelashes. And if you notice our genotypes, we're going to have 2. We're going to have a heterozygous dominant, and then we're going to have homozygous recessive. Our genotypic ratio is going to be 2 to 2. Our phenotypes, we're going to have long and short eyelashes, and our phenotypic ratio is going to be 2 are going to have those long eyelashes and 2 are going to have those short eyelashes. Ladies and gentlemen, I hope this tutorial video was helpful for you. Shout out to Katoria again, and then shout out to Mackenzie again. I appreciate the both of y'all, and I'm Travis Spivey signing off with Jordan Spivey. Peace. Y'all have an awesome day.